All right, so we're going to continue on with chapter 10, 10-3, day 1, Arcs and Chords. So we have, I think in 10-3, 4 different theorems. 3 of them we're going to cover today, and 1 we will cover tomorrow. So the first theorem is, in the same circle or congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So if the chords are congruent, then the minor arcs are congruent. Okay, that makes sense. All right, let's check out our next theorem. All right, it says if a diameter or radius, remember the diameter goes across the entire circle going through the middle, and the radius goes from the center, okay, the radius. So diameter goes across the whole, radius goes from the middle to the edge. Okay, so if a diameter or radius of a circle is perpendicular to the chord, okay, perpendicular means it makes a right angle, then it bisects, okay, or splits it in half, the chord and its arc. So because this diameter is perpendicular to this chord, that means the chord XD is congruent to YZ, and BX is congruent to YB. Okay, because it's split directly in half, and we know that because this is perpendicular. All right, so then we have our next theorem, which is basically the inverse of that conversation. So the perpendicular bisector of a chord contains a diameter or a radius of a circle. So if you have a chord and another line is perpendicular to it, then it is either the radius, which is coming from the center to the edge, or it's the diameter, which is going from one side of the circle to the other and cutting through the center. Okay, cool. So the perpendicular bisector of a chord is either the diameter or the radius of the circle. All right. So let's use this information, okay? Today's math isn't as math heavy as maybe tomorrow's math. Most everyone was able to get this assignment done fairly easily in class, so it shouldn't take too long for those of you who may have been out and need to catch up. All right, so example 1, we're going to use congruent arcs to find arc measures. Okay, so JK is congruent with LM, so if the chords are congruent based on this, then the arcs must be congruent. So if this arc's 75, what's that? Well, also 75. So these are congruent, these are congruent, and so this one also equals 75 degrees. All right, straightforward enough. All right, and in class I had them check this skill. So if the chords are congruent, then the minor arcs have to be congruent. So this minor arc is 60 degrees. Okay. So it was fairly straightforward. Let's add a little more math. Okay. So using congruent arcs to find chord length. All right, so it says in circle C, arc DE is congruent to FG, and if those are congruent, okay, then these have to be congruent, and they are congruent, so they are equal to each other. Okay, and because they are equal to each other, we can set each expression equal to each other, and then we can solve. So we'll subtract 2x from both sides. 6 equals 3x minus 9. Then we will add 9 to each side, and that equals 15, and then we'll divide each side by 3, and that equals 5. So we found x equals 5, but did it ask us to find x? No, it asked us to find fg, so now we have to use that and put in 5 for x. So 5 times 5 is 25, minus 9, that would be 16. Okay, and then in class, I gave them a couple minutes, and we checked the skill. So it says the arcs are congruent. Cool. And if the arcs are congruent, then that means the chords have to be congruent. And if they are congruent, we set them equal to each other. So 5x minus 9 equals 2x plus 3. All right, and it wants us to find RS. All right, well, in order to find RS, we're going to find x, so let's subtract 2x from both sides. Okay, let's add 9 to both sides. And finally, x equals 4. All right, but it wants to find RS, so 5 times 4 minus 9. So that's 20 minus 9, or 11. So RS is 11 units. All right. Again, it's math, but it's not stressful, not strenuous. You don't even need a calculator for it. All right. So we're going to flip it over, and we have one more thing we're going to do today. Okay. So 3, we're going to use the radius perpendicular to the chord. Okay. So we found out that if it is perpendicular, let's see, if it goes from the center, it's a radius, and it splits this directly in half. So if it splits this directly in half, well, if this half is 3.5, then this half has to be 3.5. That means the whole thing is what? Well, 3.5 and 3.5, well, that would mean the whole thing is 7. Okay. What else does it tell us? Well, also, let me see. Let's go back. In circle D, okay, arc E, F, G. So this big whole thing is 120 degrees. Okay, well, if the big whole thing is 120 degrees, how much is half of it? Well, half of it would be 60 degrees. All right. So it wants us to find EG. Okay, so it wants us to find FG and EG. Well, we just did that. Okay, so if arc EG and FG equals, all right, then EH equals 3.5. Oh, and EH equals, sorry, HG. HG. Guess I should follow the pattern. Yep. All right, substitution. We take the whole big arc, we split it in half, that's 60 degrees. We already discussed that. All right, so the segment, we're going to multiply 3.5 times 2, so that equals 7. All right. So we practiced that skill in class. All right, so PQR, the whole thing is 90 degrees. Well, if the whole thing is 90 degrees, then PQ would be 45 degrees. And if half of this chord is 6, then the entire chord would be what? 12. All right, so my arc is 45, and my entire chord is 12. All right, your assignment is out there. Make sure you show your work on paper. Like I said, most people had, actually I think everyone in 7th period who was present had no problem finishing it in the time allotted. So it should be pretty good. Okay, give it a whirl.